Hey guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential equation. So we have 2 to the power of m minus 2 to the power of n is equal to 2016. Now, as you see, because 2 to the power of m minus 2 to the power of n is equal to a positive number, which in this case is 2016, we know that 2 to the power of m is greater than 2 to the power of n. Because let's say, hypothetically, that m was equal to 1 and n was equal to 2. We would have 2 to the power of 1 minus 2 squared is equal to a positive number. 2 to the power of 1 is 2, minus 2 squared is 4. And this is equal to negative 2, which is a negative number. So because 2 to the power of m is greater than 2 to the power of n, this also means that m is greater than n because both have bases of 2. So now I'm going to set m equal to n plus some constant k. So now I have, if I plug in n plus k for m, 2 to the power of n plus k minus 2 to the power of n is equal to 2016. Now, as you can see, we have 2 to the power of n plus k, and I want to simplify this. So this is essentially in the form a to the power of m plus n. And this can be simplified into a to the power of n plus n is equal to a to the power of m times a to the power of n. So 2 to the power of n plus k in this case, this is equal to 2 to the power of n times 2 to the power of k minus 2 to the power of n equal to 2016. Now, because both terms here have 2 to the power of n in them, I'm simply going to factor out 2 to the power of n. So now I have 2 to the power of n times, now 2 to the power of n times 2 to the power of k divided by 2 to the power of n is simply just 2 to the power of k minus, now 2 to the power of n divided by 2 to the power of n is 1. So this is equal to 2016. So now I have 2 to the power of n times 2 to the power of k minus 1 is equal to 2016. Now, because 2 to the power of n, because we have a base of 2, we know that this is going to be even. Because 2 to the power of any number is even. 2 to the power of 5 is 32, 2 to the power of 4 is not 36, it's supposed to be 2. 2 to the power of 4 is 16, 2 to the power of 3 is 8. Notice how all the powers of 2 are positive, or sorry, not positive, even. So 2 to the power of any number, n, is even. Now, if we subtract 1 from an even number, what is it going to be? It's going to be odd, right? So 2 to the power of any number minus 1, that number will be odd, because 2 to the power of any number is even, so if we subtract 1 from an even number, it's going to be odd. So I have an even number times an odd number. Meaning we need to change 2016 so it's in the form of an even number times an odd number. So now this will be equal to 2 to the power of n times 2 to the power of k minus 1. Remember, this is 2 to the power of n is even, 2 to the power of k minus 1 is odd, and this is equal to, now 2016 I'm going to rewrite as 2 to the power of 5, which is even, times 63, which is odd. Now 2 to the power of 5 is equal to 32 times 63, which is equal to 2016. So I simply just wrote 2016 as 2 to the power of 5 times 63 because this is an even number times an odd number. Now this gives us two equations. We have 2n is equal to 2 to the power of 5, and 2 to the power of k minus 1 is equal to 63. What I essentially did was I set the even numbers equal to each other, and I set the odd numbers equal to each other. So for 2 to the power of n is equal to 2 to the power of 5, if we have something in the form a to the power of m is equal to a to the power of n, then this means that m is equal to n. So for 2 to the power of n is equal to 2 to the power of 5, n is equal to 5. So our value for n is 5. Now for 2 to the power of k minus 1, I am going to first start by adding 1 on both sides. So I have 2 to the power of k is equal to 63 plus 1 is 64. Now we need to find out 2 to the power of what is equal to 64. Now we know that 2 to the power of 1 is equal to 2. And if we go a little farther, 2 to the power of 4, this is equal to 16. 2 to the power of 5, this is equal to 32. So one more should do the trick. 2 to the power of 6, this is equal to 32 times 2, which is 64. So now we have 2 to the power of k is equal to 2 to the power of 6. And again, remember, if we have something in the form a to the power of m is equal to a to the power of n, this means that m is equal to n. So in this case, k is equal to 6. So now we have our value for n, we have our value for k. We know that n is equal to 5. K is equal to 6. However, remember, our original equation, this was 2 to the power of m minus 2 to the power of n is equal to 2016. And so far, we've found out our value for n. However, we did not find our value for m. But remember, we did state in the start that m was equal to n plus k. And we have our values for k and n. So we can simply plug these in. So now we have m is equal to 6 plus 5. 6 plus 5 is 11, so we have m is equal to 11. So now we have both our values for n and m. So now let's go ahead and check. So m is 11, so we have 2 to the power of 11 minus 2 to the power of n, which is 5, is equal to 2016. Now, 2 to the power of 11, I'm going to go ahead and rewrite that as 2 to the power of 5 times 2 to the power of 6. So now I have this minus 2 to the power of 5, which is 2016. Now if I factor out 2 to the power of 5, I get 2 to the power of 5 times 2 to the power of 6 minus 1, 2016. Now 2 to the power of 5 is 32. 2 to the power of 6 is 64. 64 minus 1. And now this is equal to 2016. 32 times 63 is 2016. So we have 2016 is equal to 2016, meaning our values for n and m are right. Alright, so in this problem, I have 2 to the power of 18 minus 1. So, to solve this problem, for my solution, I'm going to first start by rewriting my problem. So I have 2 to the power of 18 minus 1. And let's first ignore the minus 1 here and just focus on this 2 to the power of 18. So 2 to the power of 18, this is the same thing as 2 to the power of 9 times 2. So I just wrote 18 as 9 times 2. And now an important property of exponents is that if I have something in the form a to the power of m times n, this is equal to a to the power of m to the power of n. So in this case, I have 2 to the power of 9 times 2, and I can rewrite that as 2 to the power of 9 to the power of 2. So, going back to my original problem with the minus 1, I get 2 to the power of 9 to the power of 2 minus 1. And now 1 is the same thing as 1 squared. So I'm going to rewrite 1 as 1 squared, so I get 2 to the power of 9 to the power of 2 minus 1 squared. And the reason I did that was because now I can use this property, a squared minus b squared is equal to a plus b times a minus b. So I have 2 to the power of 9 squared minus 1 squared. So a is 2 to the power of 9, and b is 1. So now I get 2 to the power of 9 plus 1 times 2 to the power of 9 minus 1. Now what is 2 to the power of 9? Well, 2 to the power of 9 is equal to 2 to the power of 3 times 3. And remember, if I have something in the form a to the power of m times n, this is equal to a to the power of m to the power of n. So this is the same thing as 2 to the power of 3 to the power of 3. Well, what is 2 to the power of 3? 8, right? Meaning this is equal to 8 to the power of 3, which is equal to 8 times 8 times 8, which is equal to 512. So 2 to the power of 9 is 512. So now I get 512 plus 1 times 512 minus 1. So 512 plus 1 is equal to 513, and 512 minus 1 is equal to 511. So I get 513 times 511. And now there is a simpler way. Instead of multiplying these two using the normal method, like this, there is a faster and more efficient way to do that. And how are we going to do that? Well, I'm going to rewrite 513 as 500 plus 13, and 511 as 500 plus 11. So this way, I can distribute the 500. So I get 500 times 500, which is 500 squared, plus 500 times 11, plus, now I can distribute the 13, times 500 plus 13 times 11. Now it's much easier to solve this. 500 squared is 250,000. And 500 times 11 is 5,500. 13 times 500 is 6,500. And finally, 13 times 11 is 143. So now I'm going to add all these up. 5,500 plus 6,500 is 12,000. 250,000 plus 12,000 is 262,000. And 262,000 plus 143 is equal to 262,143. So my final answer is 262,143.